We introduce Elite, efficient Gaussian head avatar from a monocular video via learned initialization and test-time generative adaptation. We generate a high-quality, authentic, and animatable Gaussian head avatar from a monocular video captured casually by a user. The input to Elite is a single monocular video capturing the target identity. Elite leverages two heterogeneous priors to compensate for the missing visual cues inherent in monocular observations. First, a 3D data prior, which provides a reliable initialization of the 3D avatar. Second, a 2D generative prior, which provides augmented synthetic views and expressions of the target identity. By combining the best of both worlds, Elite synthesizes an animatable Gaussian head avatar represented with two D-Gaussian primitives. Once the avatar is synthesized, it can be driven by any facial expressions at test time. Our efficient avatar synthesis pipeline can reduce the user-side efforts required to build their authentic digital self. Elite comprises two core modules, a 3D data prior and a 2D generative prior. For the 3D data prior, we propose a mesh-to-Gaussian model that translates mesh UV maps into dynamic mesh-aligned 2D Gaussian parameters. Trained on high-quality multi-view face captures across diverse identities and expressions, this model enables the feed-forward initialization of an animatable 2D Gaussian avatar from a monocular video. For the 2D generative prior, we design a single-step diffusion enhancer that generates detail-enhanced avatar images from a clean reference and noisy Gaussian renderings. Leveraging generative modeling, it enhances renderings from any view or expression using only a single reference image, providing rich supervision for the avatar creation pipeline. While our 3D data prior is trained on high-quality scans, it is inherently limited in terms of scale and diversity. As a result, the feed-forward initialization produces an avatar that is reasonable but lacks authenticity. To bridge this gap, we perform test-time adaptation. By fine-tuning the general-purpose 3D prior on a few video frames, we create an identity-specific prior, achieving a high-fidelity, authentic avatar. In Stage 1, we perform test-time adaptation using real images as supervision. Given an input monocular video, we first estimate the canonical mesh geometry and texture UV maps, along with expression coefficients, which serve as driving signals. These inputs are processed by our pre-trained mesh-to-Gaussian prior model to initialize the 2D Gaussian parameters. Finally, we fine-tune the model by minimizing the rendering loss between the synthesized avatar renderings and the ground truth video frames. In Stage 2, we incorporate generative supervision to address limited generalization. Despite Stage 1 adaptation, the model may still produce blurred artifacts in extreme views or expressions not present in the input video. To resolve this, we employ our pre-trained 2D generative prior, the single-step diffusion enhancer. We sample random views, render the avatar, and enhance these renderings to create clean synthetic targets. We then minimize the rendering loss using both real video frames and these generated images, ensuring high fidelity across diverse viewpoints and expressions. Note that our 2D generative prior generates clean synthetic targets, grounded by the 3D avatar rendering. We highlight the advantage of our avatar grounding strategy over existing 2D priors. Existing methods, like Cap4D shown on the left, generate images from pure noise. This lack of detailed visual guidance often leads to ID hallucination, where the identity shifts or artifacts appear, and requires a slow iterative process. In contrast, our 2D generative prior starts from coarse avatar renderings rather than noise. By grounding the 2D generation in this 3D prior, we strictly preserve the target identity and accelerate the inference speed. Overall, our Elite pipeline builds the synergistic loop between our two core priors. The 3D data prior plays a grounding role. It stabilizes the 2D generator, ensuring identity consistency and enabling fast inference speeds. In return, the 2D generative prior feeds back into the 3D prior to improve its generalization. The 2D generative prior provides high-quality supervision for in-the-wild test setups. Together, They form a mutually reinforcing cycle that solves the limitations of using either prior alone. Elite can generate a high-quality, animatable Gaussian avatar from a few sampled frames of a monocular video. The resulting avatars faithfully represent the input identity, capturing details such as hairstyle and skin tone, while accurately reflecting fine-grained facial expressions from the driving signals. Note that both the input identities and the driving signals are unseen during the training of all modules in our pipeline. We compare the quality of our synthesized avatars with recent competing methods. Given input video frames of an unseen identity and unseen driving expressions, we visualize the animation results produced by each method. While competing methods struggle to capture detailed or extreme facial movements, our Elite achieves superior avatar reconstruction and animation quality. Please refer to the main paper for more details. Thank you for your attention.